Assalamualaikum and good evening to everyone. We are from 2BEZ, Section 1/1. My name is Muhammad Amiruddin and my friend.
My name is Mustafa Hazim bin Muhammad Razif.
My name is Nurnilamsari binti Salim.
My name is Siti Khatijah binti Mahintan.
Okay, we are here today to discuss about AM transmitter and AM receiver. For introduction, the receiver is demodulation and the transmitter is modulation. For receiver, demodulation is a process of extracting the original information signal from a modulated carrier wave. A demodulator is an electronic component that is used to recover the information content from a modulated carrier wave. There are many types of modulation, hence there are also many types of modulators. The signal output from a demodulator may represent signals such as sound, an analog audio signal, image, analog video signal, or binary data, a digital signal. For transmitter, in electronics, modulation is defined as variance aspect of a high frequency continuous wave carrier signal with an information bearing modulation waveform. For example, an audio signal which represents sound. The carrier wave will carry the information. When it reaches its destination, the information signal is extracted from the modulation carrier by demodulation. Now, I'm passed to my friend, Katie.
Thank you, Amiruddin. So I will present the block diagram of the AM transmitter and AM receiver. For AM transmitter, carrier oscillator will carry the original signal and the original signal will go through the buffer amplifier. At buffer amplifier, the signal will damping and amplify. After that, the signal will transmit to the modulated class C power amplifier. At this point, the signal will fully modulate and the signal will transmit to the antenna of transmitter. The antenna will transmit the signal to the receiver antenna. For AM receiver, the antenna receiver will receive the signal and the signal will go to the RF section. At the RF section, the signal still the modulate signal and has noise. So that's why we filter the signal by using the band pass filter. After that, we go to the converter section, and at this point the signal will demodulate. After that, after demodulate the signal has noise, and again the signal will filter by using the band pass filter. And then the signal will go to the IF section, and also we call it as envelope signal or original signal. After the signal after the envelope signal, the signal will filter again because of the noise, and after the filter after the signal filter, and then go to the AM detector. After that, the signal will filter again using band pass filter before the signal go to the audio section. And then the audio section the signal at the audio section will transmit to the speaker that we will hear now. So thank you. I will pass the presentation to Mustafa Hazim.
Okay, moving on to our circuit. This is our full circuit for transmitter and receiver, but it will be cut into two, such as this is the AM transmitter, which is at the top one. This is the receiver, AM receiver, which is from at the bottom one. Okay, for the function generator at the transmitter, this one will represent as the carrier signal, that the signal, or should I say data, that we want to transmit to anyone anywhere. For this function generator, it will represent as an intelligent carrier, or intelligent carrier that you might know from our previous lab session. Okay, during the simulation, we have used for the carrier frequency is 5 and the amplitude is 6. As for the intelligent frequency, we have used 100 kHz to modulate the signal so that it can amplify the signal of the carrier, so it can be bigger, so that the receiver can receive better the signal. At the beginning of the circuit, in the function generator over here, the waveform represent the violet one is represent as carrier signal. And it will go through here, and then after that it will be modulated. As you can see, this one, the blue one, the modulated signal, so that it can be transmitted, so that it can be sent off to anyone in the world. Because in theory we cannot data because of there is lack of damping and everything. After we transmit the signal, the modulated signal, it will came here for where the receiver is, and then the modulation process will start. And here we can get the result for the modulation signal, the green one. And after it receives the signal, it will have the process through the diode and everything. And for the output signal, we will get the original signal sent by the function generator over here. But as you can see, this sign form is not exactly the same, because over the course of from being modulated and then transmitted through the air and then received again and then to be filtered again by the diode, it will require and gain a lot of noise, so that is why we can see over here this is not very same. But actually the data is same, but it come with all sort of noise throughout the modulation and demodulation and throughout the transmitted feed. You can see this is the modulated. It's for the Z. As you can see, the voltage is 23. The V peak, and here is this, because when you transmit the signal, the voltage becomes more. That is why, because you need in the block diagram, you need the buffer amplifier. That is all for my part. Thank you. For now, I will present my presentation to my teammate Nurnilamsari.
For the discussion, basically we will talk about the process that occur in previous slide. Modulation is a process where the parameter of a waveform are varied proportional to the other waveform. The modified parameters are depend on size modulation provided. Basically, modulation process requires two modulation signals, which is information signal and a carrier signal. Modulation basically occur in transmitter. Then it can be assumed that modulation is a process where modulated signal waveform was transmitted from transmitter to receiver. On the receiver side of the signal, the modulation received is converted back to the origin. So this process is called demodulation. Demodulations occur in receiver. Network used for modulation process is called a modulator, while the network used for the process demodulation is called the demodulator. Information signal usually have a low spectrum and sensitive to noise. Before transmission happen, it requires a signal which has a high spectrum, and the modulation is needed to move the spectrum from the data signal from low bandwidth to a much higher spectrum. It's done on wireless data transmission with antennas. By increasing the frequency data used, then the dimension of the antenna used will be shrink. So the next presenter is Ami.
Okay, and now we proceed the conclusion. Based on this experiment, we can conclude that the advantage of an AM transmitter of carrier wave change according to the intensity of the signal, the variation in amplitude of a carrier wave. After that, the amplitude modulated is not constant, but has a similar sinusoidal variation as that of the signal wave. The amplitude modulation is simple and widely used. The research have successfully investigated the reliability of AM transmitter and AM receiver. Initially, that was determined as easy to read should have no problem reading and understand the assignment report. Changes were taken to improve the reliability of the assignment report, but this has result in a negative impact on the readability factor. In general, the improved assignment report is slightly more difficult to read and understand as compared to initial lab manual. However, these changes were thought to be critical and important to ensure student understanding in the lab section. Okay, that's all from us.
Thank you.
Thank you.
Thank you,
Assalamualaikum.
everyone.
Bye.
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 Bye.